All right, let's jump right in. When you think about the future of robotics, what's the first thing that comes to mind? Is it sleeker designs, maybe faster processors, or more powerful motors? Well, for years, that's exactly where the focus has been. But what if I told you the biggest thing holding back truly smart robots isn't the hardware at all? What if the real bottleneck isn't the robot's body, but its brain?
This one idea right here, it completely flips the script. It changes everything we thought we knew about the challenges in robotics. You see, the physical bodies of robots are getting incredibly capable, but their brains are, well, they're starving. They just don't have the huge structured experience they need to understand our messy, complicated world. So the race isn't just about building better bodies anymore. It's about building better brains. And brains are built on data.
And look, this isn't just some small roadblock. We're talking about a foundational crisis for what's called embodied intelligence. That's the whole science of giving robots minds that can operate their moving bodies. And honestly, it's all happening at the worst possible time.
Because, make no mistake, the demand for these kinds of smart robots is absolutely exploding. I mean, from manufacturing and logistics to healthcare and even just help around our homes, we want robots that can do more, understand more, and adapt on the fly. The pressure to deliver is massive, but the very foundation we're building on just isn't ready for it.
So that's the big question, isn't it? If the demand is through the roof and the hardware keeps getting better, what's the real holdup? Why don't we have general-purpose robots helping us out in our daily lives yet? Well, it all boils down to a few really critical problems with, you guessed it, data. Let's break these down real quick. First, we've got fragmented data sets. Just imagine every single robotics lab in the world is learning on its own, in a vacuum. Their data is stuck in these little silos, which means a robot in one lab can't learn from what a robot in another lab just figured out. Then there's the high cost. It is incredibly expensive and takes forever to gather good, high-quality data for these robots. And third, poor multimodal alignment. This one sounds complicated, but it's simple. It's when a robot can't connect what it sees with what it does. It's like trying to learn piano by reading sheet music, but you're not allowed to hear the notes or touch the keys. It's just total confusion. Okay, so that's the problem. It's a big one. So how on earth do we fix this broken foundation? Well, the answer seems to be creating a totally new, shared infrastructure for robot intelligence. And this is where a solution starts to come into focus. And that central idea is called co-data. You can think of it as a shared data layer for all of embodied intelligence. Now, don't think of it as just one giant database. It's more like a universal operating system for robot learning. A common ground, right? A shared library of experiences that any robot from any company, anywhere on the planet, can tap into to get smarter way faster. This is the kind of shift that could just exponentially accelerate every. So how does this actually work in practice? Because it's not about just building a bigger data pile. It's about creating a whole new kind of data ecosystem, one that's built on a few really key principles.
So this whole new ecosystem is built on 4 critical pillars. First up, scale. We need an internet-sized amount of data to teach robots how to handle the zillions of things they'll see in the real world. Second, structure. The data can't just be a chaotic mess. It has to be organized, standardized. Third is ownership. This is huge. It actually encourages companies to contribute their super valuable data by making sure they keep control of it. And finally, and this is the secret sauce, closed-loop usability. This means robots don't just learn from the data. They go out, they try to do tasks, and then they feed their new experiences back into the system. This creates a cycle where everyone's robots are getting better, all the time. And this, right here, this really highlights the huge shift in thinking. The old way of doing things was all about getting a high score on a specific controlled test, a benchmark. But this new approach, it's focused on one thing and one thing only: performance in the messy, chaotic, unpredictable real world. It's the difference between a student who's great at acing multiple choice tests and a surgeon who can actually perform the operation.
You know, at the end of the day, all of this tech, this entire ecosystem, is designed to be human-centric. The goal isn't just to make smart machines for the sake of it. It's all about building a foundation that will let us create robots that can safely and effectively work right alongside us, helping us and making our lives better. So, when we look out at the horizon, the future of robotics really does look like it's going to be a shared one. We're moving away from this idea of isolated labs competing against each other and moving towards this collaborative ecosystem where shared experience becomes the fuel that powers the next great leap forward. And this really frames it perfectly. This isn't just a new product or some platform. It's really an invitation to be part of building the foundational roads and bridges for an entire industry.
It's about literally constructing the intelligence infrastructure that the next generation of truly helpful, capable robots is going to be built on top of.
Which leaves us with this final, really powerful question. What actually becomes possible when a breakthrough that one robot makes in some corner of the world can instantly become a learned skill for every single robot on the network? When intelligence isn't isolated anymore, but shared. The potential there isn't just a little bit better, it's exponential. And that is a future that's definitely worth building.